Okay, so this is then the energy changes knowledge test. Okay, and what we're going to do is we're going to go through all the facts that then you need to know for this. What is the activation energy of a reaction? So what that is the minimum amount of energy particles need to react. Okay, so it's absolute minimum amount of energy that is required. Draw a labelled energy graph for endothermic and exothermic. So endothermic, right? So what I'm going to do here is I'm going to do the axes, right? Obviously that should be a straight line. This side here is energy. I'm going to do the same thing here. I'm going to go across there. This side here, I'm going to be lazy. I'm just going to write down E. Then what I'm going to do is I'm going to draw my graph, which goes across there, and it goes up, and it stops there, and it goes across. And for this one here, I'm going to start there, I'm going to go up, and I'm going to go down, and I'm going to go across there. Okay, label it up a little bit, right? So what we've got here is we've got the reactants, whoops, and then we've got the products. Okay, so that is then what is made, and we've got products. Then what we've got to do is we've got to know the activation energy. So the activation energy is the amount of energy required to make the reaction happen. So what it does, it goes from there, it goes up to there, and it goes to there. That is the energy required for an endothermic reaction. The activation energy on an exothermic reaction is from there. So it goes from where the reactants are to the peak of the graph. All right. The last thing is that the energy then that is absorbed is that amount of energy. So that is absorbed. Okay, hence why it's endothermic, it's taking in energy. An exothermic reaction, that is the amount of energy released. Question number 3. Complete the following reactions, metal and acid. Right, so what I'm going to do here is I'm going to say lithium and hydrochloric acid. Metal plus acid makes salt plus hydrogen. Okay, so what you've got to do is you've got to remember metal plus an acid makes a salt plus hydrogen. And people always think when you say salt, you're thinking of sodium chloride. Now you're not. So what you're going to do, the salt is you're going to combine the lithium with the non-metal that's involved in here. So it's lithium chloride plus hydrogen. Now it's not balanced, all right? Balancing comes at another stage. Metal plus oxygen makes a metal oxide. Okay, so what I've got then is I've got my metal, I'm just going to do sodium, and I've got oxygen. I react them together. What I do is I make NaO, which is sodium oxide. Again, it's not balanced. It's just showing that when you've got a metal and you've got an oxygen, you combine them together, you make a metal oxide. Right? An alkali and an acid. What we do is an alkali and an acid, we get a salt plus water. Right, so I'll just use pink for this one. So an alkali could be NaOH, and an acid could be hydrochloric acid. NaOH, I know NaOH is an alkali because it's got OH at the end, and I know that's an acid because it's got a H at the start. Right, so what happens is the Na and the Cl go together, making a salt, which is NaCl, plus water, which is H2O. A metal carbonate and an acid. So I make 3 things on this. I make a salt plus water plus carbon dioxide. So if I've got a metal carbonate, I'm going to go NaCO3 plus HCl. I keep on using hydrochloric acid. The salt will be a combination of that and that, which will be NaCl. I then make water. and I make carbon dioxide. So the only hard part about that is working out what the salt would be, because you're already told that water and carbon dioxide is made. A hydrocarbon and oxygen. What we always make on that is we make carbon dioxide and water. Okay, there is no kind of salt that's involved in it. Question number 4. What are the 4 physical states and their state symbols? So we've got solid, liquid, gas, and then the weird one is aqueous solution. State symbol S, L, G, A, Q. Flipping out, got it the wrong way around. Question number 5. What are the 4 steps to calculate bond energies? Now this is a higher topic, alright, so just be aware. The first thing you do is you calculate the energy in. Alright, what that is bonds breaking. Okay, so if I've got an equation, I've got an arrow in the middle there, and I've got these substances, and then I've got the substance on this side. The first stage is calculate the energy in, so it's how much to actually break those. Number 2, what you then do is you calculate the energy out, and that is then the bonds made. Okay, so this bit here is then the bonds made. So first part, the left hand side is calculate the energy in, it's breaking the bonds. The right hand side is then making the bonds. Number 4, I then need to know the energy change. And to do that, I will do energy in, take away energy out. Okay. If the answer is positive, it is endothermic. Don't be silly. Endothermic. If it is negative, it is exothermic. And so what that means really is that if it's exothermic, there's less energy in there than there was previously, which means some of the energy has then come out. If it's positive, that means there's more energy in there than there was originally, which means energy is